simpler way to do it is this way. Method 2 is by following the definition of the Fourier series by using those two equations, and mainly this equation. Okay, so I write again the signal xt. Xt is cosine 10 pi t plus cosine 20 pi t. And from the definition of the, we want to write it this way. K equals minus infinity to plus infinity, ak exponential j omega naught k k omega naught k omega naught t. And we need to find, we want to find those coefficients, and they are given by this equation, by this integral, 1 divided by the fundamental period, integration over 1 period of xt exponential minus j k omega naught t dt. And as we have seen, t naught is just it was 1 over 5, and omega naught is 10 pi. So we have t naught is 1 over 5, and omega naught is 10 pi. So if we substitute this omega naught here, we get 1 over 5, which is the period. And then the integration, we can do it from t naught divided by 2 minus t naught divided by 2 to t naught divided by 2. We can do it from 0 to t naught. It's the same. I'll do it this way, from minus 1 tenth to 1/10. So for a duration of just 1 period. The period is 1 divided by 5. We go from minus 1/10 to 1/10, which is just 1 period. And then xt, I write cosine omega naught t. Omega naught is 10 pi t plus cosine 2 omega naught t times exponential minus j k omega naught t dt. Next, I write those using the Euler's formula. So 1 divided by 1/5 is 5, and it's 1/10, 1/10. Okay. We write those using Euler's formula again. This is not the smartest way to do it, but I'm just showing that you can go through this, but this will be very long by using the definition. But in the previous one, we used the Euler's formula. We directly found the coefficients. Here we'll use the Euler's formula, but we're going through the longer path, just to show you all the calculations that we need to do to find the coefficients. So if we use the Euler's formula for this, for those two cosines, we get exponential have 1/2 here, exponential j omega naught t plus exponential minus j omega naught t plus also the two exponentials for this cosine is exponential j 2 omega naught t plus exponential minus j 2 omega naught t, and then all multiplied by exponential minus j k omega naught t dt. And if we distribute this term, we get 5 divided by 2, 1/10, 1/10. This will be exponential j omega naught times 1 minus k t plus exponential minus j omega naught 1 plus k t, and then plus exponential j omega naught 2 minus k times t plus exponential minus j omega naught times 2 plus k times t, and then all of these are inside the integration dt. Okay. If we do this integral, we'll get this 5 divided by 2 time. We'll do the integration for each term of those, and then we get this 1 divided by j omega naught 1 minus k times exponential j omega naught 1 minus k times t, this between minus 1/10, 1/10 plus or minus minus 1 j omega naught 2 plus k exponential minus j omega naught 2 plus k t minus 1/10, 1/10, then minus 1/10, 1/10, and then we have plus j omega naught 2 minus k 1 divided by j omega naught 2 minus k exponential j omega 2 minus k t minus 1/10, 1/10 minus 1 divided by j omega naught 2 plus k 2 plus k exponential minus j omega naught 2 plus k t minus 1/10 plus 1/10. then when we substitute those two limits of the integration in this exponential, we will get, I'll just write the result here, 5 divided by 2. Let's see. If we substitute omega naught equals 10 pi, we get 1 divided by 2 1 divided by 2 times sine pi 1 minus k divided by pi 1 minus k plus sine pi 1 plus k divided by pi 1 plus k plus sine pi 2 minus k divided by pi 2 minus k plus last term pi 2 plus k divided by pi 2 plus k. And as you know, those are just the sinc functions. Sine x divided or sine pi x divided by pi x is just the sinc function. Right? So we get 1/2 times sinc pi 1 minus k plus sinc pi 1 plus k plus sinc pi 2 minus k plus sinc pi 2 plus k. Okay.
Is that
Now,
just something you just have to memorize or something? Or
which part?
the sync function?
Oh, the sinc is defined this way. This is the definition of the sinc. The sinc x is just, I think I'm supposed to drop this by, be sure. The sinc is defined this way. Sinc x is just sine pi x divided by pi x. This is the definition.
I see. All right.
Yeah, it's just defined this way. But it has those properties that you should remember, I think, is that it's 1 when x equals 0. When x equals 0, this, if you try to find the limit for this one at x equals 0, it will be 1. And it takes value 0 when x is an integer. So at multiples of pi, this will have nulls, zeros. If you remember, its shape is something like this, and then right, something like this, and this is its value at 0, which is 1. And those nulls are at pi, 2 pi, 3 pi, and so on. Okay. So 1 at 0, 0 at the integer multiples of pi, and then otherwise it will be just sine pi x divided by pi x. So, otherwise, it will be just as it's like the definition. Okay. So if we get back to this, here we have sinc 1 minus k, sinc 1 plus k, sinc 2 minus k, and sinc 2 plus k. So if k equals 1, if k equals 1, this term will be just 1, right? And the rest of the terms will be zeros, because this will be just an integer, this will be an integer, and this will be an integer. So we get sine pi times some integer, and sine pi and all of its multiples is 0, right? Sine at pi and any multiple of pi is 0. So the sinc will be 0 also at any integer multiple of pi. So all of these terms will be 0 at k equals 1. Then when k equals minus 1, this term will be 1, right? Because it will be sinc at 0, and as we have said here, sinc when x equals 0, it will be just 1. So this term will be 1. The rest of the terms will be zeros. So 1 minus 1 will be 2, and this will be 2 minus 1, which is 1, and 2 minus 1, it will be 3. So integers. At any integer, the sinc will be, at any integer multiple of pi, the sinc will be 0. So let me write what I have said here, but in a better way. So when k equals 1, then ak, or a1 in this case, a1 will be half times the first term only. The rest, the three remaining terms will be zeros. So we just 1/2 times 1 plus 0 plus 0 plus 0. So it will be just 1/2. When k equals minus 1, a minus 1 will be 1/2. The first term will be 0, but the second will be 1, the third 0, the last one 0. So it will be just also 1/2. In this case, the second term is 1 because k equals minus 1. 1 minus 1 is 0. The sinc at 0 is 1. When k equals 2, then a2 equals 1/2 times which term? The third term will be 1. So 0 plus 0 plus 1 plus 0, which is again half. And k equals minus 2. We get a minus 2, 1/2, 0, 0 plus 1, which is 1/2, which is the same as we have got as we have seen in the first method. Ak is always 1/2 for k equals minus plus 1 and minus plus 2, and 0 otherwise. and we have got the same thing, but this is a longer way. And whenever you see cosines or sines, you shouldn't go that way. You should directly use the Euler's formula and inspect what you get to see the coefficients. And then this coefficient at k equals 2, this coefficient at k equals -1, this coefficient at k equals +1, and this coefficient at k equals +2. This one is at -2, this one at +2. So yeah, so this one I write it here A2, and this one is A1. This one is at A-1, and this one is at A-2. Okay. Just by applying the Euler's formula directly. You shouldn't use the second method, which is applying the definition. Don't apply the definition if the function is as simple as this one. Now I have a second example, which is simpler than this one.